Welcome to the Develop Yourself podcast, where we teach you everything you need to land your first job as a software developer by developing yourself, developing your skills, your habits, your network, and more. I'm one of your hosts, Aaron Hayslip, and today it's just me. We're talking about React. This is going to be a complete background overview of what React is, how it came about, and its basic components. I think this is a great episode to listen to if you've been learning React and you want some more broader context for what React is and its concept. We're going to dive pretty deep technically, so it's advised that you have a base level understanding of JavaScript, that you've worked with HTML and CSS, and that you've probably built something in the browser, something even, as simple as you're listening for a click, you click the button and something happens in response. Anyway, I hope you find this episode helpful. Okay, so I've been teaching React to brand new developers since essentially a couple of years after it came out. I think my first bootcamp, we taught it in 2015. And back then, obviously, React wasn't all the hotness. I think it came out in 2013. But the best way I've learned to sort of tee up React is by going through a history and explaining that React doesn't exist in a vacuum, right? It was built by developers to solve a very specific problem. And if you can understand the problem behind React, what React solves, then I think it will give you a much deeper understanding of React. I think one of the problems we see with beginner developers is you go through these tutorials, you learn the how of something, but you don't learn the deeper why. So you end up being able to copy paste an application and build something. But as soon as you have to build your own application that is different than the types you've been building in tutorials, you don't know how, because you don't understand the why behind the framework, and you don't understand technically the design pattern level of why it was built or how it's even architected under the hood. So we're going to go through that in depth right now. So I want to start by just defining React real quick. That's where we're going to end up. And then we're going to go back in history and look at the way websites have essentially evolved. So if you're not familiar with React, which I'm assuming if you're listening to this episode, you've at least heard about it. React is considered a front-end view framework, right? So it gives you the ability to basically build very interactive websites. Now, if you know the basics of web development, then you know that every website is built using three primary technologies. There's HTML, which is obviously the structure and information of the website. There's CSS, which applies the styles, that's the formatting, the colors, those kinds of things. And then there is JavaScript, and JavaScript is what provides the interaction. Literally, JavaScript will dynamically manipulate HTML and CSS to make a web page interactive. So again, hopefully you know all of that already. What React does is it essentially helps supercharge the JavaScript development of that application. And that's because applications these days are incredibly complex, right? There's a lot of moving pieces. We're going to get into that in a second. But having a framework to help you do that easier, quicker, better, faster is not only ideal, it's necessary these days, right? And React, by the way, just to kind of give you an understanding of what a JavaScript framework is in general, anytime we're thinking about a framework that's written in a specific language, so let's say in a CSS framework, a JavaScript framework, a Python framework, we're thinking of code that's been written for you that you can use, right? Someone's defined the function and you can use the function to do something else, right? So you're still writing the code, but you're building off of code that's already been written. So a really simple example of that is, let's say that you want to find the average of the numbers in an array. So this is JavaScript. We've got a data structure called an array, and an array in JavaScript is simply just a list. So you've got a list of numbers. Let's say you've got test scores in a fourth grade class from the standardized test, and it's numbers 0 to 100, and there's a list of 20 of them, right? And you need to find the average of all those. Well, JavaScript doesn't have an average function. There's not a built-in function to find the average. So let's say that I build this library. I'm going to call it my math library. And it's going to give you a bunch of functions that enable you to do quick common tasks. So finding the average, finding the sum, finding the median, finding the max, the min, all those kinds of things. And so one of the things I would write is a function called the average function. Now, as the user of my library, all you have to do is give my average function a list of numbers and it will give you the average, right? You don't need to know what's happening under the hood. And this is a concept called abstraction, right? We can abstract away certain things that you don't need to know about how they work, and it allows you to think about higher level things, right? And sort of I don't know if it's a great example of this or analogy, but is a car, right? If you ever driven a stick shift car, and I do, I have an old manual car, I have to use one of my hands the whole time I'm driving to shift my car. And there's a part of my brain, it's pretty, automatic right now, but it's a part of my brain that has to think about shifting. Whereas if I were to get into an automatic car, like my wife's car, I don't have to do that. I have another free hand. I can drink a coffee. I can, pass food back to the kids. It's a minivan or whatever. And so that part has been abstracted, which allows me to do other things. And that's the same thing with libraries or frameworks. And by the way, quick distinction between library and framework, kind of the same thing. You can think of if you're building a house, a library might be, hey, we're going to build a whole house. You can use like the nail and hammer and all the manual tools you have, or I'm going to give you access to Home Depot and you can literally have any power tool you want. Like that's a library. It helps you do things better, quicker, faster. It abstracts, how to screw a screwdriver because the drill does it for you, etc. But it doesn't actually teach you how to build the house. Whereas a framework might have an opinion on, it doesn't tell you what type of house to build, but the framework might tell you, okay, here's all the Home Depot tools. Here's also some best practices, right? We got to start with a concrete slab. And then I'd advise that you get some 2x4s together and you frame those out. Oh, we've got a built-in framing nail gun. It's a special nail gun that's good for framing. And then we should do the plumbing and electrical, yada, yada. You get what I'm saying. So that's kind of the distinction between library and framework. So anyway, coming back to my math analogy, we might build a math framework or math library so that you could use that. And that's really what React is, right? It's a series of functions, JavaScript code that some developers have given you and said, hey, you don't need to know all the things about how React works under the hood. You can just build seamless views. You can build seamless websites and not have to think about that. You can think about other things, right? Which is amazing. And by the way, React has a counterpart called React Native, which allows you to easily build mobile applications. So on the iPhone or Android, and huge companies worth billions of dollars basically build their entire business, the front ends, using React for the web and then React Native for their phone. So you as a developer don't have to step out of JavaScript to learn Swift or Java or whatever to build the mobile applications. So it's extremely powerful. So that's kind of what React is. We haven't really talked about exactly what it is or why it's unique or from a developer perspective, but that's what it does. It helps you build websites and applications much quicker. And it abstracts away a lot of the stuff that you'd have to otherwise think about as a developer and allows you to think about other things, building bigger, badder, better, faster apps. So let me talk about the history of sort of web development. It's not that long of a history in where React comes into play, because I think what you're going to find out is that React isn't anything new. It's just the logical next step. And there are many other flavors of frameworks that exist today that are like React that essentially solve the same problem. They just solve the problem a little bit differently. So I think obviously it's 2023. React has won, but a few years ago we might have said maybe Angular Plus or Vue, and those are still popular, and there's some others too. But anyway, so the history here that we want to think about is the way websites evolve. So when the internet was first launched, and I won't go too deep or technical into this, but I remember this as a kid, right? I was born in 1989, so I was a young 90s kid, right? So I was young in the 90s, but I remember getting AOL for the first time. I think my email address was amhayslip09@aol.com. I think my mom created it. 09 stood for my age. So I was 9 years old. I had my first AOL account. We could go on the internet. And I remember sitting with my mom thinking, this is so cool. We always hear about people going to like these different .coms, like in the web browser. I wanted to know like, where is that URL bar, right? And we found the URL bar in the AOL browser, and we were like, well, what websites could we go to? It's like, I don't know. We just started like pulling products around our house that had websites on them. I remember like Coca-Cola, like we had a can of Coke and we spun around the back and it said, I don't know, maybe it was Coke.com or something. And we're like, oh my gosh, let's go to Coke.com. And when you get there, what do you see? Well, it's sort of like the newspaper, but on the internet. That really was what the internet was back then. It was just information, articles. You were consuming information. And so the websites themselves were not very complex. The JavaScript underneath the websites, when JavaScript did exist on the internet, it wasn't that complex. It wasn't really until the internet started evolving, really in the early 2000s, did the websites themselves become more complex. And then really probably around 2008, 2009, what we saw then was websites started becoming more interactive, more user friendly, right? You could do more stuff. There was more data, more information. Everyone had their own API. Developers were building more open source software. There's just a lot going on. Obviously, Facebook, Google, Gmail, it just took over. And from a developer's perspective, the leading technology then was jQuery, right? And what jQuery allowed you to do was the same thing that the basic DOM APIs of JavaScript allowed you to do, but allowed you to do it better, easier, faster with less code. Write less, do more. That was kind of their slogan, I think. So if you think about it, let me explain real quick what the DOM APIs are. They're essentially ways to manipulate HTML with JavaScript and the browser. So they can listen for button clicks. They can add items into the DOM, which stands for Document Object Model. It's the way that the browser reads the HTML and basically builds out a web page. So they could add, remove, manipulate, even animate HTML and CSS so that it makes your web page look and feel interactive. And the thing that really tipped the scale here, that made things go from, hey, we've got, that sort of forced the technology to evolve quickly, was this concept called Ajax. And Ajax is less a actual technical breakthrough than it is a technique. And the term Ajax, which stands for asynchronous JavaScript and XML, and it's a technique that was, it's a term rather, that was coined by Jesse James Garrett. He was, and I presume still is, a user experience designer that basically wrote this article. And the idea of Ajax was really built off of this technology called the XML HTTP request. And it essentially gave the browser abilities to perform HTTP requests with JavaScript. So an HTTP request is basically the language of how a web application or web server interacts with another server. So anytime that you're on the internet, let's say you're on Facebook, because it's just a basic example, and you want to post a new post, you want to write something, you write it and then you click the post button. And what actually happened under the hood is an HTTP request, a post request is in this case, gets sent from your browser where you're at, right? And it gets sent from your browser to whatever server that Facebook has. And ultimately what's actually happening is there's a physical location that is going to store the data of your post, right? It doesn't actually get stored on your computer, it gets stored there. So the way we do that is we basically send this mail using HTTP. Now, up till now, most of the time, whenever you would send these requests, it would cause an entire page refresh, right? And that's what we were used to, is what we consider multi-page web applications. And a multi-page web application is, the kind where you're at a website, you see the about page, the contact page, and every time you go to a different page, it refreshes the entire browser and shows you new information, right? That's the newspaper. But what we were starting to get now, where you would want to see new data instantaneously without refreshing the page, right? Again, think about posting a post on JavaScript. You post it, you want to see it there right away. You don't want it to have to refresh the browser. So the XML HTTP request enabled this request to happen. And then AJAX, this asynchronous nature, was a technique in which you would do that request without refreshing the page. And when you look at the page, there's probably only one small section of the page that actually needs to be updated, right? So instead of updating the entire page by refreshing, you would just update using JavaScript and CSS that one, and HTML obviously, that one part of the page that needs to be updated. So to the user, it would feel instantaneous, right? And think about every application you use. This happens all the time. You are going to edit one small part of the app, but the rest of the app is still going to be intact as you're editing that one part and as you're updating the data of that one piece. So coming back to the tech side of that, this was all being done, right? New applications were popping up that could do this, mostly using jQuery. And again, jQuery is a library, not a framework. So it gave you a bunch of new tools, but it doesn't necessarily give you a way to structure your data and information. And then around 2009, this just got out of hand. And we saw several front-end web frameworks pop up that told you, hey, we've got to organize this in some fashion, because if you're building an extremely complex UI, you just got all kinds of janked jQuery everywhere that's causing all these different parts of your page to re-render. It's slow, it's disorganized, and it's a mess. You'd click this one thing expecting something to happen, and it wouldn't happen. If you've ever tried to build an app, a web app with any kind of complexity with jQuery, like, you've experienced how hard this is. In Parsity, and this has been like a long time project I've always had. In Parsity, one of the things that we have students do is you build a simple like Reddit clone, but you can only use jQuery. And most people fail it in the beginning because it's just so complex. So let's deep dive here on one of the frameworks that came out during this time. Obviously, Angular, Ember, Backbone, those were kind of the big three that we saw, with Backbone and Angular really being the primary ones. So Backbone, which if you're a past student of mine, you'll laugh because we used to teach Backbone up until very recently, because it forces you to do some of the things I'm about to talk about. It makes you think about things that React doesn't make you think about, which I think in some ways is a good thing. So what Backbone was it was a way to apply an MVC pattern. So MVC stands for design pattern. And whenever you think about MVC on the front end, a lot of times they would refer to it as an MV star framework. So meaning as in the basic concept of M is that you have a model, V is a view, and then depending on the framework, you either had a C for controller, you might not have had a C because you only had the framework only had a model and a view. You might have had what they called a presenter. There's different ways to think about these design patterns depending on the framework they use. But the basic concept was this. In JavaScript, you want to separate out the data of your application from what the user sees. And so, yes, ultimately they're going to see HTML, but you're going to have some JavaScript that generates that HTML somehow. So you would have, we call this, again, the MV pattern, the data is the model, and the view is the V, MV, saying MV star. And here were some of the basic principles that a framework like Backbone presented. One is you need a single source of truth. Like, your model is your single source of truth. And what you had here was all the data of your application. Again, this isn't the database. This is your client-side data. So let me give you an example here. Let's say that you're building a very simple Reddit-like application. And the first thing the user sees when they open up the Reddit application is just a series of posts. Let's say they see 50 posts on the page. Now, obviously, what happened behind the scenes is your web app made a GET request to whatever the server is to get those 50 posts. They come back to your page and you have to display those posts. So likely what you're going to do is you're going to put those posts in an array called posts, right? And then from here going forward, what happens when that array, that post array changes, right? So there's a few levels of changes that might happen. You might edit one of those posts. You might delete one of those posts. You might add another post to that post array. You might reorder them. There's a number of different things that you could do. And you want to not only change that information, but you want to re-display that. And every time you're doing that, by the way, in a real web app, you'd have to then make a request off of the server to make sure that it looks the same, so that when another user comes to the application and they make a request to the server, right? The server's kind of the middleman. It looks the same. So the complicated piece here is you need to make sure that it's easy for you to manipulate that data. And it's far more expensive to manipulate the actual DOM, like the literal HTML that's in there, than it is to manipulate the data structure behind it. So in this case, what you basically have is you would have a model, which is the data, and you would have like its corresponding view. So you'd have the same quote information represented in two ways. One of the ways it's represented is in the JavaScript code, which the user can't see, in an array using JavaScript data structure. And then the other way it's represented is using HTML, actually what the user can see. And you want to treat one of those as what we call the single source of truth. So which one of those is the one that we're going to believe if there's ever some sort of conflict in information? And that's really where, Backbone was a shining example. It forced you to kind of organize this code. And so one of the things that was created out of this was this idea of unidirectional data flow. Now I'm getting nerdy here, but bear with me because everybody who's ever built in Backbone has to know this. And the idea of unidirectional data flow is the following. Think about a diagram that acts as a circle, and there's an arrow, and the arrow is pointing in one direction around the circle. In the circle, you've got three things along the path of the circle. The first one is what we call an event. So this is the way data is going to flow through a MV star / Backbone application. The first thing that's going to happen is a user is going to do an event, right? And that's a generic term for they're going to do something. They're going to click a button. They're going to scroll. They're going to reload the page. They're going to edit something. They're going to type, whatever. An event's going to happen. This event tells us, hey, y'all, someone is updating our information. How are we going to display this? Like, what's going to happen? So as soon as the event happens, the first thing we do is we don't update the DOM for the user. We first consult our single source of truth. And that is, in this case, our model. And this, if we're building the Reddit-like app, that's our post view, right? Our post model. So we go tell our model, hey, and let's imagine, for example, that they added a new post. So there was 50 posts before. There's a post array, got 50 posts in it, and we added a new post. We're going to say, hey, model, turns out we want to add one more post. So we're going to add a new object to the post array. That array now has 51 items. And then next, we're going to go to our third step in the circle, which is going to be our view. And we're going to say, hey, view, guess what? The posts array got updated. You should update according to the post array. Listen to it. And then the view is going to re-update now according to the post array. And now our app is ready to listen for more events. And the circle starts over again. So every time we make a change, we update the model, and then we change the post array. Now, there's a few benefits of doing it like this, of having sort of that model middleman. Let me give you a scenario here. Let's say that you've got 50 posts, and they've all got a different number of upvotes. We need to make sure that we display the posts by upvotes. So the posts with the most upvotes are going to be at the top, and then they're going to be ordered in descending order from there. Now, let's say we have a button in our application that allows you to sort the posts. And so you're going to click, and this is common, right? We do this all the time. Every app has a button like this. So you're going to click sort, descending. And right now, by default, the array is unsorted. It's just random in terms of their order. And so if you didn't have a model, right, and all you were trying to do is use like jQuery or some kind of DOM API to sort the post, you'd be basically using all of these read functions in JavaScript to walk through every one of these posts and to examine parts of the HTML that would be, obviously constructed as strings. You'd have to convert those to numbers, store those somehow, and then reorder the DOM. Every time you reorder the DOM, it's a new write to the DOM. And reordering and manipulating the DOM, not only is it expensive, like it's crazy expensive. It takes so much power, and it's long, and it makes the website slow. Not only is it expensive, but then how are you going to communicate this back to the server? How are you going to tell the server that this user reordered this so that next time they pull it in, it has the right order? Well, it's a mess. But if you're using our MV design pattern, we know that if the user clicks the button, right, this is an event they're taking, to sort the posts, then the first step we have is not to consult the view, the HTML, but it's to consult the model, right? And in our case, our model looks like, and by the way, Backbone has its own implementations of all this. I'm using pseudocode to just simplify things, but our model is an array. And y'all, how hard is it to sort an array in JavaScript? Not hard at all. How expensive is it? Not expensive at all. How simple is it? Insanely simple, right? So what we do in this case is we resort our array according to posts or to upvotes, and then the view responds by re-rendering. And how does it re-render? Just delete the big div that has all of the stuff in it and just rewrite it, right? That's the idea. And that's literally what Backbone did for about 5 years, like a boss, and just dominated front-end web development with this, which was, let's just separate it out. Let's have a unidirectional data flow. And whenever the model changes, let's update the DOM. Now, this got complex though, and that's where we're getting into React. Because the developer had to think through this architecture with an insane amount of precision and detail. The developer literally had to wire up. So if you think about like a large application, you would have many models, and you'd have many views, and you'd have to connect them all together. And for every property on your model, right? In this case, we only had one property, we have posts, but we might have many more properties. A Backbone developer had to write code that said, all right, this view needs to listen to the properties on this model. And when this specific property changes, we need to invoke this function, update the HTML in this exact way. And it could be really hairy, really quick. And they even made other libraries and frameworks that set on top of Backbone to make it even easier. It was just a mess. And so Facebook came along, and if you've ever been to Facebook, the website, you don't notice it, but the application has so many things going on that I can imagine as a JavaScript developer is just insane to handle each one of these little areas. Not only that, but if you think about a large company, there are probably 50, I don't know how many front-end engineers, probably way more than that at Facebook, but that are actually managing the web application. And every one of those little parts of the organization has their own job to play. And with Backbone, it was just too complex. I don't know that, Facebook sat down and said, hey, maybe we should use Backbone, but they definitely did not think that what existed was going to work for them. So they built React. And this happened in 2013. They released it publicly. They've open sourced it. Anyone can jump on and use React. And I remember being at a company in 2014, and it was kind of like the cool thing that we weren't actually using React, in production. We were using Backbone, but everyone was thinking, man, this React thing is pretty cool. So that being said, I want to real quick explain how React sort of addressed some of the issues that we saw in Backbone. And to do that, I obviously need to explain how React works, which was kind of the point of this episode. But I think all this background information is probably where the juice is at. So let's talk about React. What is it? What does it do? How is it different from other frameworks like Backbone? And how does it really turn the MV design pattern up on its head a little bit, but it's still sort of the same thing. So whenever React came out, it was a different way to think about, and technically it was different as well. It was a much less lightweight, that's the opposite way of saying it was a heavier framework in terms of the code written under the hood was far more advanced and complex than something like Backbone. With Backbone, if there was an error, I would just like jump into the source code and read how every little thing happens under the hood. Like I could tell you every line of code, what it does if you showed me the source code. React, I don't think I've ever looked at the source code before, to be honest. And that's, maybe roll your eyes at that. There's probably a lot of people who have. But React introduced a few new concepts. One of the concepts was this idea of a virtual DOM, which has gotten a lot of, interesting perspectives on it. I don't want to dive too deep into it because, to be honest, I'm not like super introduced by React and is by no means exclusive to React these days, is the virtual DOM. And to be honest with you, I don't really know much about the virtual DOM or understand its intricacies, but I do know the following, that one of the difficult pieces about Backbone, for example, is if you're going to re-render part of the page, right? How do you know which part of the page to re-render? Like you have to write the code to manually tell the page which things to re-render. And depending on the way that you write that code, you may write good or bad DOM manipulation code. And by the way, in Backbone, you mostly use the jQuery ultimately to do a lot of the manipulation. So you don't know if like reordering this div was performant or not. And so with React, what React would do is it would create, and I think it does, by the way, I say it would, but it does. It creates a virtual copy of the actual DOM. Because as we said, every time you edit the actual DOM, it's expensive to read and write from it, either to like get information or put information in there. So it would create a virtual copy, which would essentially be a JavaScript tree, right? And so the DOM itself is a JavaScript tree. You have a hierarchy of sections, divs, different kind of elements. And so it would create a tree copy. And then whenever you would edit one of the items in that tree, you would use advanced JavaScript concepts to effectively manipulate the parts of that tree that should be updated in the quickest way possible. And one of the things, you always hear from React is React will essentially write to the DOM once, and it will write to the DOM, and then it will the most proficient way possible. And one of the things that you might have heard about React is to never use an outside library along with React. And that's because React needs total control of the DOM. And the reason why it needs total control of the DOM is because React is not, for the most part, reading the DOM. So if you update the DOM some other way other than with React, React doesn't know it because it's trying to read from the DOM as little as possible. It's using its virtual copy and it's assuming nothing else has changed. So you only want to use React if you're using React. I mean, there's no real reason to use anything else with React. Anyway, so that's one thing, is it makes updates super quick. Now, where it helps a developer in actually writing code is the following. Let me explain how React works. React basically tells you to think about the finished product of your application. Let's just look at it, right? Get it all down like a designer would build it. Now think of the data of your application, and let's break up that data by little components. So every little part, every little view of, if you're looking at like a large app, for example, and you've got posts over here and comments over there and your profile button, all that, those would all be small individual components. And each one of those components needs to be fed data, right? And whenever it is fed that data, it knows how to display that certain type of data. So this is the idea of React. React basically is a library, or a framework rather, that helps you build out web components. Now, one of the central themes of React is that each of these components, if you're building a view component, it takes props, right? It has properties, and you can feed it data, and it knows how to interpret that data and then how to render it. And of course, by render, we mean make it, visible on the page. So this helps you reuse these components, right? So you don't have to rewrite the code. This helps you update these components quickly because all the component knows is that it takes props and it displays these props. So let me give you kind of a real world example of this. Let's say you're building a car factory, right? And you know that every car is going to be basically the same. It's going to drive, it's going to have 4 wheels, it's going to have 4 doors, yada, yada, yada. So you just build a basic car component, right? And you're going to use a lot of them because you're going to make a lot of cars. Now, every car has properties, and these properties might be unique. You might want a green car. You might want a red car. You might want a blue car. You might want a blue car that goes fast. You might want a red car that goes fast or slow or has leather interior or it's electric or it's gas. There's all these different properties. And so if we're thinking about in terms of React, we could just build a car component. And the car component could take engine type. It could take a color. It could take interior. And then depending on the data that we feed it, all it does is it will display those things, right? That's the central idea of a React component is it takes props and it will use those props to render something, visually. This isn't a data manipulating thing. This is an actual, we're not thinking in terms of like constructor functions necessarily. Now, here's the cool thing. Whenever one of those props changes for whatever reason, right? The component itself is as dumb as possible. It doesn't know why its props changes, but suddenly one of its props changes. React is built in such a way where it knows how to intelligently update the view however it needs to update, right? So as a developer, what has been abstracted away from you is the need to go and find, okay, here's the data that got updated. I need to go make sure that the data tells the view to re-render. I need to tell it what to re-render and when, why, how. I mean, those things all happen in Backbone. And so what it's enabled is for developers to no longer have to think about the actual re-rendering process. I mean, there is some thought that needs to be had into that. You need to know how React does its rendering. But to think about that far less and then to build much more complex applications, but in a simple way. Then I think the last element here that I want to get across with React is this idea of state. And everyone always confuses state and props. And the way you can think about state is, in React, by the way, there's literally a data structure that you have for your React application where you keep, sometimes it's application wide, sometimes you have different versions of state, but you keep data that exists outside of the life cycle of your component. So in other words, the way your Reddit app would work in this case from a perspective of React is you would fetch all of the posts from your server. You would then put them in an object called state, and then you would send different parts of that state object to different components. And parts of that state object would map to different components. And the component doesn't need to know anything. It has no logic. It can just display whatever data it's given. So all of your logic can be written separately. And again, this comes back to what we were talking about before is with the MV pattern, in some ways, this is what's happening in React 2 is we're separating out the data, which is the state of our application, from what's being viewed. And just wiring it up seamlessly and helping you build your applications much faster. All right. This has been a long episode about React where we didn't talk about React too much, but I think this is what needs to be talked about. There are plenty of episodes on React and how it works out there in the world, but I don't think there's a lot going over sort of the history and the why of React and why React has made these decisions. And I hope knowing that this is the point of React will help you build bigger, badder, better applications faster. All right, that does it for today's episode of the Develop Yourself podcast. Check out our online code school, Parsity, PARSITY.io. Always check out our 30-day JavaScript course called Dev30. It's dev30.xyz. Again, we're going to focus on your habits, your skills, your network, your mindset, everything that you need to become a software engineer is, or at least a JavaScript novice, right? That's what we should say. It's not a course to become a software engineer. It's a course to become the kind of person who should become or could become a software engineer. All right, we'll see y'all next week.